Hello everyone and welcome. Today I would like to talk about interval list intersections and I'll be using the two pointers approach. In this question, you are given two lists of closed intervals. First list and second list, where the first list I has star I, and second list J has star J and J. Each list of interval is pairwise disjoint and in sorted order. It means that within each list, the intervals do not overlap themselves and they are already sorted uh, in their own order. And the question asks you to return the intersection of these two interval lists. So what's the closed interval? A closed interval AB means that for a set of real number x with x always between a and b are inclusive, and a can be less or equal to b. An intersection of two closed intervals are a set of real numbers and that are either empty or represented as a closed interval. So when they are empty, it's like 5, 5, 24, 24, it's empty. A closed interval, 1, 2, 8, 10, yeah, that's a closed interval, okay? And so let's think about how to solve this problem. And first of all, let's look at the constraints first. So those are the intervals, and you also know star always less than n. Okay, star always less than n. It's always between 0 and 10, 1 billion. And so you get a sense that it's in a ordered, and the first length and the second length are always larger than 1. So one of them can be 0 and the other can be 1. And so at least one of them have elements. Okay. So think about how to solve this problem. So let's think a little bit deeper into this question. What do we mean by intersections? How do we detect them? So here are A and B, the intervals, and there are 5 ways they intersect with each other. And in each of them, we notice there's a generalized expression here, which is the A star is less than or equal to Bn, and B star is less than or equal to An. So if this is satisfied, then we have a intersection between the two intervals. And then importantly, the intersection should be the maximum of the two stars and the minimum of the two ends. So that's the intersection. And importantly, this generalized expression can also take care of these edge cases. So the result of these two intervals will give us an empty interval. Next, let's see how we are going to traverse through the given lists. Let's use the example here. Let's say we use two pointers to track indices in these two arrays. And once we compare the intervals, either an intersection occurs or did not occur. For example, 0, 2 intersect with 1, 5. So, and an overlap or intersection is 1, 2. Then moving to the next comparison, because the lists are already sorted and disjoint, the interval whose n was smaller will never intersect with any further intervals of the other group. For example, the 2 in 02 will never intersect with all the other elements of the other group. Thus, we may increment the pointer of that group, the first list in this example, by 1 after each comparison, namely moving to the next element in first list, but keep the pointer of the other group, the second list, the same, so still point to the first element. Now we have thought through the question, develop our algorithm, and think through all those edge cases. Now let's try to implement in the coding. So, so first of all, we will use two pointers, let's say I and J, to track the two arrays. Okay, and then the question here is where the first list I, so those are the elements J, and we want to see if the star, this is the star, A, so A star, I call it A star, A, N, okay, and we call this B star, B, N, okay, and then the question is whether there's an intersection between these two. So if A star less than or equal to Bn, and the B star less than or equal to An, intersection occurs. Okay, and our result will be the list. So if that occurs, we append that into our result, and that will be the maximum of 2 stars and the minimum of 2n. Okay, and then if not occurring or occurring, then we'll move on to the next comparison. In the next comparison, we want to see which n's came first. So if an less than or equal to bn, so an came first, then we discard it. So I plus equal 1, else j plus equal 1. And we will do this while I is less than the length of first list, and j is less than the length of the second list. Okay, and finally we will return the result. So let's use a test case to verify our coding. Okay, so here's the test case. Let's verify our code using this test case. So we begin with I and j equal to 0. So it points to this 0, 2, and 1, 5 element in the two respective groups. And first of all, we want to see if they overlap. So it satisfies this condition since 0 less than 5, 1 less than 2, and the overlap will be 1, 2. So intersection, the result array now is 1, 2. And now the n, 2 less than 5, so the 2 can never be intersecting with any other further element in the second group. So I plus 1, J stay the same. And then now it's 10 and 5. So here there's an intersection, but it's an empty array. So it would be 5 here. So it seems to be working. So now let's test this code to see how it works. Submit, pending judging, and done. So it's successful. And finally, we will analyze for complexity. So for time complexity, so let's say we have L1, the length of the first list is L1, and the length of second list is L2. So here we basically need to go through L1 and L2. So L1 plus L2, and the space complexity will also be O L1 plus L2, okay, for the result array. And that's all for this question. Hope you find it to be useful, and hope to see you next time soon. Goodbye.